Hello, everyone. I see that we still have people who are joining to our webinar. Today, we'll be talking about this hot topic about the inference, so beyond ChatGPT, unlocking the power of open source LLMs. I believe we can proceed. Okay, so yeah, let's talk a bit about our agenda for today, what we will be discussing. So first, it's going to be intro, couple of slides about us as a company. After that, we're going to be talking about open source models versus private endpoints, how to choose and what to use. Also, we're going to be talking about like how to choose an open source model for your specific case. All you need to know about alternative providers that are like arising now. And after that, we will have a small demo uh, where I will show you how like the things can be done that I'm going to be presenting during my presentation. I'm a machine learning product lead in Nebius. I oversee ML products such as Operator. So if you are also, apart from inferencing, doing some high scale training and you experience some issues with fault, like I don't know, sometimes GPUs go down and so on. We just release our new solution. It is open source. You can use it wherever you want. You just need a Kubernetes, and you will have a Slurm on top of it with a lot of fault-tolerant features like monitorings, hardware monitorings, and so on. Moreover, I'm also a product lead for Nebius Studio. That is the product that we're going to be discussing a bit today, but the main topic is like about the whole inference stack. I have more than 10 years of experience in different areas of IT. Like I have an engineering background, cyber security and development. Who are we? But before that, maybe we can have a quick poll to say, who are you? Like, what are you doing? What are your main? So they're going to be polarized soon. Yeah. Yeah, Nebius. So we are a global company. We have our headquarters in Amsterdam, where I'm currently located. We have more R&D hubs all over the world in Europe and North America, Israel. We're a global AI business. While Nebius is like the largest company in our group, we also have an ed tech, self-driving cars, and other businesses. We are a Nasdaq listed company, so we're trading. So we also have a lot of money in cash, and we have quite an infrastructure. So for you to get the scale, like we currently have like our own data center built from the ground in Finland. We also have data center in France. We're gonna have one data center in United States really soon, and we have like points of presence with R&D hubs like all over the globe, I would say. And yeah, we just released a new product, Nebius Studio. And while we were like making product research and development, we found a lot of stuff that might be interesting to share. So that's will be the materials that I'm sharing. The main idea of this product is that it's inference for open source models with per token billing, and I'll be talking how to choose like an inference provider, how to choose a model, and so on. So yeah, I believe everybody noticed that there are a lot of different applications that are now arising. Some of them are copilots, like code copilots, or maybe some grammar checks. There are a lot of chatbots and also design software. And what is common with all of them, that all of them are using inference. And uh, yes, so what is inference? Basically, it's when you have some trained model and you apply it to a specific task, so you inference it. And to understand the scale, why it's a problem, inference need a lot of compute. For example, to generate one token with 405B model, so one of the state-of-the-art model, Llama 405B, you need to do one power of 12 operations of multiplications. And that's quite a lot. It's just to generate one token. It's not to generate a sentence, not to generate, I don't know, a book, just one token. And one token is basically like 4 characters, like a bit less than one word. And it's the same amount of operations that you need to decode like 4K video, or also decompress like multiple gigabytes archive. Of course, like the multiplication operations are a bit different in the world of inference. Like it's not integer, it's floating points, and usually the like the data type is not that big, but still like to understand the scale, that's quite a lot. And yeah, and we see that currently, like there was a trend that training was like the biggest thing, and it's still like this as we see it today. So every new model that is getting released, it's like a big news. And yeah, but what the problem with the training that it's like spends money. With inference, you can like get money because you are making all of this application that I was showing you a couple slides ago, and you can make some business model around it. And so we are expecting that inference is going to be growing. And if you are here with us on this webinar, probably you're going to the right path because like, yeah, they're going to be a big market here soon. And yeah, when we're talking about inference, I believe everybody knows how to use ChatGPT and uses it within their applications. But also, as I said, like when the new model released, it's always a big news. And why? There is like a couple of answers. First of all, right now, open source models have the same quality baseline. So when they are just released, they get the same like scores on the most popular benchmarks. Here you see like the scores of Llama 4.5b when it was released. Also, we're talking about smaller models and they have their own use cases. They also like beat quite a lot of benchmarks. And what's good with open source models? You have more options. So you have cheaper models, you have more expensive models, you have models that are specified for specific tasks. And yeah, that's good. But how to navigate them? That's what we're going to be discussing today. And also, these models usually can give you better pricing because you can deploy them within your infrastructure, go to some alternative providers that might provide you a better price. And if you also have some privacy concerns and you don't want to send your data to, let's say, OpenAI, and you want to have like a specific provider who you can trust, open source model give you this variety of choice. So yeah, if we look at like state-of-the-art model market, we can see that like here it's a graph like quality versus price, and that's our like top-notch models for now. And with the same quality baseline, open source model can give you like much better pricing. So yeah, depending on your task, you might be really concerned about prices, especially when you have a scale. And in terms of like state-of-the-art models, there is definitely some other options. And if we check the small models, so I don't know if your application doesn't rely too much on reasoning or some specific tasks, there might be a situation when like 8B model is enough for you. We're going to be discussing how to understand if it's enough. And in this case, you can have like the best offering. Like here you can see there is one private endpoint here somewhere in the middle. But if you want a bit better model or like a bit cheaper model, there are like options. And yeah, and moreover, if we're talking about like an exact open source model, there are many providers for these models, and you can choose even with the same model, even different characteristics. So like speed or price and so on. Obviously, if you want the model to be faster, you usually need to pay more. And yeah, so how to navigate through this whole model list. That's what we're going to be discussing. Let's decide that we want to build some kind of application, and let's go through all the steps, what you need to think about during building this app. So first of all, modalities. Obviously, there is like text model. We're going to be talking a lot about them, and the price vary a lot, and the market is quite formed there. So like the cheapest option would be something like a couple of cents for 1 million of tokens. The most expensive would be like dollars per 1 million of tokens. So yeah, the variety is big here. You can get also different generation time. Also, there are vision models. They're quite the same in terms of pricing as a text model. The only difference that one image is usually counted as some specific amount of tokens. There is also image models when you generate an image instead of putting it into the input. In this case, there is also like a lot of options, other market, audio recognition, audio generations, and so on. So let's decide. I'm building an application. I want a text model. So I'm building, I don't know, maybe a chatbot or maybe some kind of copilot, and talk a bit more. So, okay, we decided on the modality, and all of the modalities have their own specific benchmarks. And it's not just one benchmark per modality. It's more like depending on the capabilities you're expecting from your model. So what you want to provide with your application, there is a specific benchmark for that. For example, if you want a chatting model, you might go to LLM Arena and check like Chatbot Arena, like this course there, and probably get the model that suits you. But you might be looking for some tool usage, so you want to make your model do prediction of what tools you should be executing. In this case, there is like a specific benchmark for tool usage, like API benchmark or BFCA. And in this case, there are some options that will be much cheaper than like the top-notch model, the ChatGPT, but with the same quality. And when I'm saying much cheaper, it's like 10x cheaper or maybe more. So yeah, what we need to know, you know your domain better, you understand which benchmarks might be useful for you. Are you expecting a model to be good at reasoning, or maybe you're doing some code model? So check the relevant benchmark with you and at least understand the set of models you're expecting. After that, we will need to think about like the speed, and the speed is also like not one characteristics. It can be divided in three of them. The first one is time to first token. So if you're streaming your answer to the customer, the most important part is how long does he wait till the first token arrives? Because after that, the speed should be just faster than he reads. So it's something like 10 tokens per second, an average person read speed. And that is a baseline that almost every model like gives. But the time to first token may vary. So when you're like checking the model, checking the provider, check this characteristic. Also, there is this user throughput. For example, when you want to build some chains, so one model generates some answer and you want to take this answer and put it as an input to the second model. In this case, you want to the whole end-to-end time to be fast, and you need to also check the user throughput. So how many tokens are generated per second. Also, if you're building inference on your own, you might also check the system throughput. So how many tokens you can generate per one device or maybe per one provider. So yeah, that's important when you understand the scale of your system. There is also such a term as latency. I would say please do not use this term just because every provider, every company perceive this term differently. For example, in artificial analysis, it's like TTFT. And for example, for Databricks, it's TTFT plus like it's basically end-to-end latency. VLM operate like it's an open source popular inference engine as end-to-end latency, inter-token latency. So if you're saying latency, it can be vague and not like straightforward. The terms that I'm talking was talking before, like much better to understand your use case. And also one more important characteristic of the model is like a context window. Right now, I would say almost all the model provide like 128K context, and that's quite a lot. Like, for example, Harry Potter and the Philosopher's Stone consist of 96K words. So it's basically like the context window. And you can put the whole book into one prompt and ask something like what Harry was wearing when he first met Hagrid. And this is the problem that is called like a needle in the haystack. There is a specific benchmark for such models, and the model might answer you correct. And so, yeah, you need large context in the cases like when you need needle in the haystack problem. If you want to do some summarization tasks, also if you're doing some retrieval scenarios, like you are having some specific database where you're getting your context and feeding the model, that's the case where you need to understand like what is the context size of your model. And like for the most, like for the biggest, the context sizes right now is Gemini, and it's 2 millions, and you can fit like the biggest book that was ever written by Marcel Proust in Search of Lost Time. The next thing is price, and here it's not that straightforward as it might look on the first glance. So yeah, but basically there is input and there is output, and these prices may vary from provider to provider, and some providers provide you the same, like input costs the same amount as output, so like $1.5 for a million of tokens. Some providers provide you different, and the best formula to understand which case suits you the best is not just the average across these two numbers. The better price formula is still not the best, I would say. 3 multiply input plus output and delimiter that by 4 divided by 4. But I would say what we are now like experiencing with our product, that the most popular case is more like 10 to 1. So for example, let's look at this case, and yeah, like an average case, you're feeding like 1,000 tokens and getting like 100 output tokens. And in this case, we have like two providers. One provide the same price, and it seems to be slightly less, like 1.5. The second provider provides $1 per input and $3 per output. And if we will benchmark, like try to understand how much you will pay for 1,000 prompts, as we discussed, like in an average case, the second provider will be better. So what I'm saying, if you know your task, what you are doing, you should understand this ratio and you should check your economics and understand which price suits you better. The next thing, like the model, how to choose. Like, as I said, there is smaller models, there are bigger models. When small model is enough. So basically, I'll be talking about that. And yeah, so how to determine this? When you have your application, you might be tested this application with your like first customers, and you understand how it should be working, how should be answering if it's a chatbot, or how should this model should be summarizing the text. Out of this data, you can make a golden data set. So it's a data set with pairs like user inputs and desired output. After that, you can evaluate like every model you have with this golden data set. And after that, you might understand like, okay, this model is enough. And probably like the state-of-the-art models will be working good enough for your case, but smaller model won't. And after that, you can change a configuration a bit. Like you can tune a prompt that you're feeding into the model. Like you can set a system prompt, okay, please act as you are a good assistant or as you chatbot of the bank application or something else. Also, you can fine tune the model on the golden data set, like you already collected it. You should like get some part of this data set and fine tune it and test the same metrics on the rest of the data set and understand, okay, now this baseline is better, this baseline is enough. And then you can like go in cycle and reiterate this as far as you're getting more data in the golden data set, as far as new models are arising. And you will understand like what suits you the best. And here on the down of the slide, you can see that, okay, there are like three models, the smallest, medium, and the biggest. And you can see that prices vary, and that's quite obvious. But more importantly, the speed varies a lot. The smaller model can be giving you like the best speed. If you go even less than 8B, the speed can be higher. So TPS here stands for time tokens per second. And yeah, why is it happening? It's just because you need a different amount to compute just to run this model. If we're talking about models that are less than 3B, and we see that many models were released not so far ago, these models are basically can be fitted into the edge devices. So you have your iPhone or Android phone. If they have the latest chip, they probably can run these models like within this device. If we're speaking about like slightly bigger model, you usually need one GPU for them. For the medium models, you need like half of the host or something like that, like 4 GPUs. So it's like half of the server cost. And if you want to inference like state-of-the-art models, you will probably need like the quite like a sufficient amount of hardware. Like it can be 2 hosts or even more, depending on the amount of the parameters and the precision you're using for your data type. And okay, so we understood that we need some hardware for our task, but what are the options? So where to go? There are currently two types of providers, apart from hosting that on your own. First type of providers, they give you a per hour billing. So that's an example like Hugging Face model and Run AI. And in this case, you go to them, say, okay, I want this model, and after that use the endpoint. And also there are other type of providers, Nebius AI Studio is one of them, where you can have a per token price. So if you have spikes, if you have some higher demand and lower demand, that's not the case for you. You do not need to be thinking about the hour, the paying per hour. You're just paying for what you're getting. So how many tokens you proceeded through this system, you're paying for that. But that's not the only difference. So while we were doing our product, we understood that all the challenges that are usually talked about the inference can be divided into three types. First of all, it's hardware. So you just need to have the right hardware. For example, if you have a state-of-the-art model, you probably need quite a big GPUs. The second part is orchestration, and that is also solved by both types of providers. So usually when you have an per hour model with providers from the previous slide, you can stop GPU, start GPU, and they like managing like a big pool of capacity. But there is a third challenge that is maybe not this obvious. It's a model to GPU optimization. So basically, how good is your software code that is ran on top of GPU? And that's an important part, because depending on this code, you can get a different throughput from the same device, like 10 times or in 100 times. It will vary depending on how good is your code. And why so? Just because there is a lot of techniques and they're quite like deep in terms of engineering, and you really need to dig quite deep into them. For example, if you want to build inference in-house, you will need like some GPU engineers that will help you with that. But usually the providers that give you per token price, they solve these issues on their own, and you can just use the results that they're doing. Okay, so we discussed like the type of providers, but how do you interact with this provider? Obviously, like the most popular way, the same as OpenAI. So they invented this API standard. So it's a couple of endpoints like chat completions, and all or almost all of the providers support them. Also, there are like a separate thing as a batch inference. So for example, if you are not expecting to have some real-time inference and you have like a big batch of data, let's say gigabytes of data, you can push this data to the inference provider and wait till it will make be processed by the provider. You usually get a discount. You sometimes need to wait quite a sufficient amount of time, but usually if you need to process this amount of data, that's okay. Also, some providers provide you custom SDKs, and also there is like open source libraries that are quite popular, such as LangChain and Llama Index, and they have support of almost every provider. Here on the right, you can see the slide of the list of supported providers by LangChain, and it's quite a list. And okay, let's imagine that you already have your application and it utilizes ChatGPT. Is it difficult to change the endpoint? I would say the answer may vary. So like just to make it work, really easy. You need to write just 2 or 3 lines. For most of the application, just setting the right environment will work. But of course, you can go into the code and just change a couple of lines there. Of course, after that, you need to test like how good is the result you are getting with this new model, but that's a part of other story. And okay, now we will have small demo, so how we can do all of that within our studio, new product. So here are the product itself. We can authenticate into it using Google or GitHub account. So I will be using my Google account. After that, you getting into the first screen. And here you can see like the list of models. Like we provide 2 types of flavor per model. So depending on what type of model you need, should it be base or fast, you're getting a bit different pricing, but also you getting like different speed. Also here you can check the quality, context size. You can do a filter, even by task. For example, you can check which models are performs in code challenges the best. You can interact with this model basically just the same as in ChatGPT. So write me, and you will see the answer. You can change also endpoint here. There is more parameters, and there is like pop-ups that will explain you what does they mean. You can also compare 2 models. So let's check like the smallest model and the biggest model with the same task. And we can see that like different models doing different speed. And okay, the next thing that we were discussing during our webinar is like, is it difficult to change the code? No, it's not. Like here you can see a piece of code that was written using OpenAI API, OpenAI SDK, and right now it's using GPT 4.0 model. And let's check that it's working. Okay, we have an answer from ChatGPT. And as I said, like a couple of lines of code, and we will make it work with our Studio product. This basically can be done with any inference provider. And now we have answer from like Meta Llama 4.5b. Like we just change an endpoint, an APK, and the name of the model. The same things go to the LangChain. So this is like a simple piece of code that is performing some search, and after that, like answering the question that I'll be asking. For example, what is Nebius AI Studio? Okay, we now we're using the OpenAI API for that. So the model is doing, it's like loading the tool, initializes the agent that will do some search into the Google, and then we will have the answer. Okay, Nebius AI Studio is the platform for experimenting and building, integrating AI models into applications. Okay, let's try to go with the different inference provider. Same, just change the APK, name of the model, and the endpoint address, and we will have probably the same result in a second. Okay, one more search, and the answer. Okay, it's a platform that simplifies the creation of generative AI apps. So yeah, we have quite a bunch of plans within our product. We're gonna add more models. We're gonna have fine-tuning services, per token inference for LoRa adapters, eval services. And if you are like expecting of using such services, or maybe you're already building some application already and you're using some of them, please vote into this small poll that we are offering just to know what is currently trending, what like you would be expecting from such providers. And also, like, we encourage everyone to test our product. You can just sign up using this QR code and you will get sign up $100 grant. We also launched a competition, so build an application. Authors of the top 3 projects will receive 1,000 grant. You can check more info via this link too. And also we are like looking for strategic design collaborators. We are ready to give them even more in grants. If they are ready to collaborate with us, we want to be like have clients and build trust with them. We're ready to do some joint partnerships. Yeah, just write to the email that is written here. And yeah, so what we discussed today, we discussed when open source model can be used instead of private endpoints that we covered, I believe, how to choose model for inference. So we discussed like the price issues, the speed, how you should measure all of that, how to understand which benchmark suits you the best. Also, we talked a bit about an alternative provider. So all of what we were discussing also applied to them. And we checked how to substitute like OpenAI or any other private provider in any framework. So yeah, that's all for the webinar itself for today, and I'm ready to go to the Q&A session. I will check the questions in the chat. I believe I had quite a help there with the team that is doing AI Studio. So yeah, what do we have here? So the first question is like, are there any open source models that are free? So it depends of what do you mean by free. Like when you release an open source model, they all have some license. We also have this license in our platform, so you can check and understand will it suit you or not. The main idea that like, for example, Llama or Mistral, when they're providing their model, they're saying that they're free in terms of like you can use them on your own, but for executing these models you need to like have to use a bunch of compute, and this compute is obviously not free, and that's why you should be paying for inference provider, or you should be just renting out the GPUs. The next question, what would be the benefit of buying the models instead of creating your own models with good quality data we already have? Will buying guarantee accuracy? Yeah, that's also an interesting question, and the answer would be like training a model is quite a job. It's not like something you can do in-house within your computer. For example, for training Llama 405B, Facebook used 2 clusters of 24K GPUs, and like every GPU costs something like dollars an hour. And yeah, that's quite a sufficient amount of compute that you needed, and you need to invest a lot to get the same quality as these open source models or private endpoints. So basically, You might fine-tune your model. That was one of the ideas that was here that I was presenting. So you can take a smaller model and fine-tune it. So it's basically just start training from the checkpoint that provider provided when they were open sourcing the model, and you can make this model act as way as you want this model to act. Okay. So in the initial graphs, y-axis about quality of the model, how is this quality measured? Also a good question. There was a slide regarding like these are the models and their quality and price. So there was a slide with the benchmarks. This quality is just some kind of total metric from like top 10 most popular benchmarks. So it's something like average. It might not suit you the best. That's why I was also saying that if you know your specific use case, you can go through specific benchmark and check like the quality on the specific benchmark. Is fine-tuning done here or just using the model? Okay. So for fine-tuning, there is two options. You can run fine-tuning on your own. You can also use some fine-tuning service from the providers. We're going to be providing one really soon. For fine-tuning, you need a data set. So you are saying the model that this is the input, this is the output. These are like 10 or I don't know 100 examples. I want this model to do the same as I'm expecting this model to do. The interesting part here, you do not need to have quite a big data set. I would say 1,000 of examples might be enough for most of the cases. Sometimes you need to go with like tens of thousands of examples, but it's not really like millions of examples in case of fine tuning. If you have quite a narrow case, it's not that amount of data that you need to collect. You can even try to make this data in-house. Also, and for fine-tuning, as I said, you can find a piece of code in the internet that will help you fine-tune the model on your own, but also you can go to us, for example, and run these fine-tuning services, just like pushing some, let's say, CSV file or JSON file with the set of desired output for inputs, and the model will be fine-tuned and you will get it for inference. Does Nebius offer cloud machines also, or it's just an LLM hosting company? No, it's not just the LLM hosting company. It's also we're also providing cloud machines. I believe we had a couple of webinars regarding that. So today we are discussing a new product that we just released a month ago, and it's quite new for our company, and like I'm emphasizing on it. But of course, we also have a cloud. We also have self-service in this cloud. So if you will go to the main page of our site, you will see this get started button. You click it and you get into the cloud interface, and there you can rent out GPU straight away. So the main idea, you just put your card and you can have a host with 8 H100s, let's say, straight away. Okay. Why are the companies hesitating to move their models and associated solution into production? A lot of them are ending in experiments or research. So yeah, I believe the question is about, so when you doing some GenAI application, it's more like a research phase, and sometimes you are just checking if this solution work good enough, but sometimes like many companies assesses risks and they understand that probably we shouldn't do this. There is also a EU act here in Europe that like a piece of legislation that gives you more details of how the model should be used, what are the cases where you shouldn't be using AI. For example, it's obvious when you want to give some medical advices that might give a bit of harm. So you need to have a person involved in these cases. And yeah, so that's basically the reasons, because these models, they are not deterministic. So depending on the input, they might answer differently. And for example, and that's what we also calling hallucinations. And the main idea that you can fix them with using prompt engineering, fine-tuning, and building the evaluation pipeline. So you will know that your model performs the way you want in 99.99%. And that's good, but the problem here, you still have like 0.001% that model will be performing badly on your case, and it will give you like the wrong answer. And while it looks like okay, when you have a scale of millions of customers, it will be happening like every day, let's say 10 times a day and so on. So there is such a thing that is also called guardrail. So it's not an issue that wasn't treated, but the company should be mature enough to implement this kind of technique and check the answers that the model is providing to understand, is it like good enough? So like it's not a yes or no answer here. And like why? Like they're assessing the risks probably. There is a lot of questions here. Okay, the next, I'm planning to create a chatbot for my organization. I probably will use LLMs and fine tune. Also looking into RAG since my data would HTML probably data. Any resource guide? How do I go about it? I believe we had a RAG webinar already that was performed by one of my colleagues, like Boris Popov. I believe we have it on the YouTube, so you can check with this webinar. There is also some links regarding that. So yeah, that's obviously possible. You can try with it. Short example of good model fine-tuning case. Okay, short example, like, okay, the case that I really like, it's not like a case, it's more like an approach. Sometimes it's also called like a model distillation. So basically, when you just starting your building your application, you don't have a lot of usage of third-party APIs, and in this case, you might be using any endpoint you want. For example, you can use ChatGPT or ChatGPT for all or for O1 Preview, so like the most expensive one. And that's quite fine because when you have like, I don't know, tens of customers, you won't spend a lot of money. But then when you understand that your business goes up, you start to spend a lot on the cost, and you understand that this is an issue. So yeah, and this is when the fine tuning might be a good use case. So you already did some pilots. You already have, I don't know, like thousands of answers, or maybe like hundreds of thousands of cases where you had the better model that performed good enough for you. And this is the moment when you want to make some cost reduction when you go to the smaller model. So you go to the smaller model, you fine tune it on the examples that you already had within your bigger model. And after the fine tuning, you will get like the same results as the bigger model on your specific use case. And that is something that like we see within our customers. It's not like one case or two cases that we see. It's like really broad cases. The moment you have, I don't know, millions active users daily, you go to this. Yeah, so basically we're talking about good fine-tuning case. That is it. And yeah, I believe I answered all questions and answers. And okay, so thank you everybody for your time. We also have okay, we have one more question. Smaller models tuned for specific task or larger model for more than task? I believe that was basically what I was just answering. So yeah, you can use smaller model for the same task as a larger model, but with larger model you can just like use it straight away. Smaller model you can just fine tune it. So yeah, that's all for the questions. Thank you everybody for listening. Was happy to share some feedback, also like some research that we did while we were making our product. Also, if you have some feedback to our webinar, please provide it via the poll that we just published. And yeah, thank you.